Pre-algebra, Mr. Lawrence here with your flipped lesson, and we're continuing our discussion on probability. And today we're going to talk a little bit more about what we talked about yesterday, only we're going to use the terms independent and dependent. Events, okay? Independent events. It basically means that they stand alone. One event in no way affects the other. For example, if I want to know the probability of flipping a heads on a coin and rolling a 1 on a 6-sided die. So I've got a head coin, right? Look at this great artwork by Mr. Lawrence. And I've got a die. Okay. And I want to know the probability of getting a heads on one coin, on the coin, and rolling a 1 on the 6-sided die. Well, those are independent events. There is no way that flipping the coin can affect the outcome of rolling a die. They are totally unrelated to each other. They're only joined together because perhaps you're playing a game, and the goal is to flip a head and get a 1 on 6 on the 6-sided die. So to figure out the probabilities, well, I'll move these out of the way. I know the probability of getting a heads is 1 out of 2. Remember, probability is success over total. The probability of getting a 1 on a 6-sided die, well, there's 6 possible outcomes, and only one of them results in a success, and the fundamental counting principle tells me to multiply these together. So the probability of these two events happening would be 1 out of 12. Now, I could show this to you another way. Hold on one second. Okay, let me insert a little chart here. Let's see, 4, 5, 6. Okay, let me see here. I can prove this to you that it's 1 out of 6. Oops. I want that to slide down, but I don't think that is going to happen. So that's all right, but I can fill it in. Now, for example, I might get 1, 2, 3, 4, 5, 6. I might get a heads or a tail on the coin, right? And the outcomes on the die could be a 1, 2, 3, 4, 5, 6. Okay. Well, each box measures a different outcome. For example, this would be a heads and a 1. That's what I'm looking for. This would be a tails and a 1. This would be a heads and a 2, heads and a 3, heads and a 4, heads and a 5, and then a heads and a 6. And then similarly, this would be a tails and a 2, tails and a 3, tails and a 4, tails and a 5, and then a tails and a 6. Now remember, to win this game, I have to get the a heads and a 1. That's what it says right here. Okay, heads and a 1. Now check this out. Look, if I look here and see all the possible outcomes, I have 12 total outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But only one of those possible outcomes is the heads and a 1. That would be this guy right here. Oh, you can't see the green on the green. But you can tell that they used to say heads and 1 if you were paying attention. So let me rewrite that. Heads and a 1 shows up twice. Okay. So there is one success out of 12 possible outcomes, and that's what I get when I multiplied. All right, so those are independent events. Now, dependent events, we were talking about yesterday as well. I'm not sure that I use the terminology, but we're going to use it today. Dependent events. These are things where the outcome of the first one does affect the outcome of the second one. Like, for example, let's say I have some jelly beans again. Let me see, how many blue jelly beans should I have? Oh, let's go with 5 blue jelly beans. So, okay. And then let's go with 4 red jelly beans. And, okay. And then let's go with 3 green jelly beans. All right, 1, 2, and 3. All right. Now, let's pretend they're all in a bag and that we can't look into the bag. Now, let's say I want to know the probability of reaching in, getting a red, and getting another red. Okay. Well, and I'm going to tell you, remember I said it was important, that will be without replacement. With replacement would make the problem independent events. Without replacement makes it dependent because drawing out the first red affects the outcome of the second red. So let's see, let's get the probability of getting the first red. It looks like there are 4 reds in the bag, so 4 ways to have success. And let me see, 9, looks like there's 12 total jelly beans. So that would simplify, 4 thirds would, 4 twelfths would simplify down to 1/3. Okay, now we have taken the 1 red out of the bag. Maybe we ate it. Jump, 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 jump. Okay, it's no longer there. Boom, it's gone. What's the probability of getting a red out now? Well, there's 3 reds in the bag, but the total jelly beans are only 11. Okay. So I've got 1/3 and I've got 3/11ths, which does not simplify. And the fundamental counting principle says to multiply them. All right. So I'm going to multiply 3 times 1 and I'm going to do 3 times 11. But I notice this has to simplify. Had I been paying closer attention, I could have simplified these 3's right here before I multiplied. It would make my math a little easier. But since I didn't see it, I'm going to divide 3 by 3 and get 1. I'm going to divide 33 by 3 and get 11. And it's going to turn into 1/11th. And notice if I would have canceled out this 3 with that 3, I'd get 1/11. So those are dependent events. And yet I'm still multiplying. All right. So let me give you a couple scenarios here. And you can determine if they're dependent or independent events. And then you can figure out their probabilities. So hold on one second. Okay, take a look at this situation. You have a spinner with 4 colors on it, spinning like so, and you have a coin that can flip. I want to know the probability of getting a primary color and a tails. Well, you should know from art class. Oh, actually, wait, I'm not going to tell you how to solve this. Sorry. Go ahead and pause the video when you want to see the solution. Unpause it. If you're still watching at this point, the first thing I want you to do is decide, is this a dependent event or independent event? Well, the spinner and the coin have absolutely nothing to do with each other. So this is an independent situation. Oops, I need a D there, not a P. So let me try that again. This is an independent situation. Okay, now primary colors. Your primary colors are red, yellow, and blue, right? They're the 3 colors you use to mix to make all the other colors in art class. And it looks like we have a blue and a red, and we also have a yellow. So there's 3 primary colors. So when I go to spin the spinner, I've got a pretty good chance of getting a primary color. In fact, there's 3 ways to have a success, and there's 4 total outcomes. So the probability of getting a primary color is 3 out of 4. Now the probability of getting a tails on the coin, well, there's two possible outcomes, heads or tails, and there's one way to win the game, so to speak. So it's 1 out of 2. Tails wins me the game. So now I'm going to multiply because of the fundamental counting principle, and I will get 3 over 8, which does not simplify. So the probability of spinning a primary color and flipping a tails is 3 out of 8. A little bit less than 50% chance of that happening. All right, let's come down here. Now, pretend we have a standard deck of 52 cards. Now, you may not realize this, but in a 52 card deck, you have 52 card deck. That's divided into 4 suits. And you can see the suits up here on the cards. You've got a heart, you've got diamonds, you've got spades, and you've got clubs. Now in each of the suits, the cards go all the way from ace, 2, 3, all the way up to 10. After 10 comes a jack, the queen, and the king. So 13 cards in each of the 4 suits. All right, you have to understand that before you're able to do the problem. So it's a 52 card deck, 4 standard suits, and each suit goes ace through king, 13 cards. What's the probability of drawing an ace out of that deck of cards? Well, how many aces are there? Well, I have 4 aces right there, so there must be 4 aces, 1 in each suit. A total out of 52 cards. Now, I know that simplifies. Okay. In fact, that's going to simplify pretty far. I believe it's going to turn into 1 out of 13. Okay. Now, a 5 of hearts. Not any 5, just specifically the 5 of hearts. Well, and notice it says without replacement. Well, there's only one 5 of hearts in the deck. Now, if I've drawn out an ace, there are no longer 52 cards in the deck. There are only 51. And so I'll take 1/13 and 1 over 51, and I'll multiply because of the fundamental counting principle. 1 times 1 is 1. Now I'm going to do a little side work here. 51 times 13. I'm going to multiply a little differently than some of you. You use a lattice. Some of you do standard. I actually do a different way. 3 times 1 is 3. Okay. I just forgot what I was going to do. I guess I'm going to do it standard. Okay. So there's 15. 3 times 5 is 15. So I'll write down 15. Now I have to put a placeholder here. And 1 times 1 is 1. And 1 times 5 is 5. And so that'll come out to be, hold on 1 second, 3, a 6, and a 6. So that'll come out to be 663. So look at that, there's not a very good chance of that happening. Ooh, that looks terrible. Let me try circling that again. 63. All right, there we go. If you were to attempt this 663 times to get an ace on the first draw, don't put that card back, and then get the 5 of hearts, you would only expect it to happen 1 out of every 663 times you did it. Not a very good chance. Now, that doesn't mean it couldn't happen 5 in a row, but the probability of it happening 5 in a row is really, really minimal. Okay, that's it for your flipped lesson today. Have a good night, everybody.